before we do, are there any questions on 3.1? Questions on 3.1?
When did we do
3.1 was last Friday, 2 Fridays ago, because we did it before the 2-day week. Yes, I'll get it in a minute. All right, guys, so what we're looking at is the note sheet here. Now, the first part is kind of broken up into a few parts. I do have it kind of covered up. But what we're looking at is, well, this here. So the first one we have is corresponding angle and alternate interior angles theorem. So corresponding angles, alternate interior, alternate exterior, consecutive interior angles. We've covered these. We covered these a few weeks ago for 3.1. And when we talk about corresponding angles, so two lines are cut by a transversal, the corresponding angles, the ones in corresponding spots are considered corresponding angles. But what we're talking about today, what we're making somewhat a little bit different today, is that the two lines are going to be parallel. So if we have two parallel lines cut by a transversal, the corresponding angles are congruent. The corresponding angles are congruent. They're going to be the same. And if two parallel lines are cut by a transversal, their pair of alternate interior angles are the same. They're going to be the exact same angle. So the corresponding angles and alternate interior angles are going to be congruent. So for this here, well, we can see that 1 and 5 are corresponding angles because they're above the parallel line and to the left. So we could actually say that angle 1 is congruent to angle 5. We could also say that angle 2 is going to be congruent to what? Angle 3 is going to be congruent to angle, and angle 4 is congruent to angle. Because if the two lines are parallel and they're cut by a transversal, then the corresponding angles are congruent. Well, we also have that the alternate interior angles are congruent. So one of our angles that's going to be alternate interior is going to be angle 3 and angle what? 3 and? So alternate interior. So alternate, opposite sides of the transversal, and if we're interior, we are inside. So 3 and 6. Then we also have 4 and 5. And again, the name kind of gives it away. Alternate, so we're talking about opposite sides of the transversal. Interior, between the lines, inside. 3 and 6, 4 and 5. Alternate interior and alternate exterior, there's only 2 sets. Alternate interior, alternate exterior, there's only 2 sets of angles. Corresponding has 4. Corresponding is the only one that has 4. Alternate interior, alternate exterior have 2. Consecutive interior has 2. So the only one that actually has more than 2 is corresponding. Now the other 2 we have is alternate exterior angle theorem. If 2 parallel lines are cut by transversal, then the pair of alternate exterior angles are congruent. They're going to be the same. So we're saying that angle 1 should be congruent to angle 8. And angle 2 is congruent to angle 7. Yes. A little bit like a sideways S. So any questions on these so far? And again, where we're writing 1, 2, 3, 4, 5, 6, 7, 8 is really just corresponding to the 8 angles that we have here. Yes, but we didn't say that they were congruent. We just matched them up. Because if the 2 lines aren't parallel, we can't say that they're congruent. Because, and the whole reason that this works is if 2 lines are parallel, it means that they will never intersect. So the distance between those 2 lines will always be the same. So if they're going to be the same, that means that we can actually have these properties, that these angles are going to work in this exact way here. Does this make sense so far? Now, consecutive interior angles are what? Supplementary. They're going to add together to be 180. So that means 3 and 5 are going to, the measure of angle 3 plus the measure of angle 5 is 180. And we also have that the measure of angle 4 plus the measure of angle 6 is 180. And really with this here, with alternate interior, alternate exterior, consecutive interior, and corresponding, with any of these here, they're either going to be congruent or they're going to be supplementary. Whenever we have two parallel lines cut by a transversal, the angles are either going to be congruent or supplementary. So when we look at this here, so what we've said so far, we know that 1 and 5 are congruent, yes? Well, we also know that 1 and 8 are congruent. 1 and 5 are congruent because they're corresponding. 1 and 8 are congruent because they are alternate exterior, yes? Well, I know that 1 and 4 are congruent, yes? 1 and 4 are vertical angles. But we know 4 and 8 are congruent because they are corresponding angles, yes? We also know that 4 and 7 are congruent because, let's see here, 4 and, sorry, not 4 and 7. Misspoke on 7. 4 and 5 are congruent because they're alternate interior, yes? So 1, 4, 5, and 8 really are all congruent by either alternate interior, I'll get it to you in a second. You're good. Alternate interior, alternate exterior, corresponding angles, those are congruent, yes? So I'm going to pick a different angle this time. Let's say 2. Well, 2 and 7 are congruent, yes? Alternate exterior. We know 2 and 6 are congruent because of corresponding angles, yes? Well, I could say 6 and 3 are congruent because they are alternate interior angles, yes? We could say 3 and 2 are congruent because of vertical angles. Same with 6 and 7. Well, how many different angles do I have for these all 8 angles? 2. 2 different angles. We have 8 angles total, yes? But 1, 4, 5, and 8 are all the same angle, yes? 2, 3, 5, 6, and 7 are all the same angle. So we have 8 angles, but we only have 2 unique angles, yes?
So the next one, 1 and 4 is different than 2.
So 1 and 4 will have the same.
Yeah.
2 and 3 will have the same.
But they're different from each other.
Yep. Not always. Because what's one way that they could be the same? If they're right angles, if they're both 90. What do we know about angles 1 and 2? They added together to be what? 180, they make a straight line, yes? So what can I also say about 3 and 5? They had to be 180, yes? Consecutive interior angle theorem. So it's not that it's not straight. They just need to add together to be 180 degrees. Yeah, because again, it's very tempting to say that they're a straight line, but it could be that this is, I'm going to pick one, just say 80, 100. Well, that means angle 3 is 100 and angle 5 is 80. It doesn't quite match up here. But as long as they add together to be 180, this all works. Does this make sense here? For the most part, yes. There is one other theorem that we technically do have. We're just not going to list it, and that is because we have consecutive interior angle theorem, we also have technically the consecutive exterior angle theorem. Same as a consecutive interior, instead of both angles being inside and on the same side of the line, they're just outside. So 1 and 7, 2 and 8 would be consecutive exterior angles. But we just don't mention that one. Or at least the book does it. So let's look at this first example. So it asks us to find the measure. The measure of 3, the number of angles are 120. Identify the angles and explain your reasoning. So we just want to find, I just want to find all of them. So the measure of angle 2, measure of angle 3, measure of angle 4, measure of angle 5, measure of angle 6, measure of angle 7, and lastly, the measure of angle 8. So we know that one of the angles is 120 degrees, yes? What is one of the other angles that we know? 4, what's 4 going to be? How do we know it's 120? They are congruent by what? 120 and 4 are congruent. Vertical angles. Yeah, because vertical angles are congruent. And again, at this point, if we have proven that it's true, so vertical angles we've already shown to be true, we can use it. So we know that 4 is 120. So 5 would be 120 by, if we were explaining it. So 4 and 5 are what to each other? Alternate interior angles. Because two angles that are on opposite sides of the transversal and between the parallel lines are alternate interior angles. Alternate interior angles are congruent. So we know this is 120, this is 120. So we know 8 is 120. Now there's multiple ways we can say that 8 is 120. One of them is because vertical angles. 5 is 120, so 8 has to be 120. We know that 120, the one we were given with to begin with, well, alternate exterior angles is going to make 8 120 as well, yes? 4 and 8 are corresponding angles, yes? Corresponding angles are congruent. There's more than one way we can get there. Any questions on how we found 4, 5, and 8? No. So we need to find 2, 3, 6, and 7, yes? Mm-hmm. So any one of these in particular that y'all want to find first? 2. What do we know about 120 and 2? Make straight line to make 180, yes?
So just 180.
180 minus 120 is 60. So angle 2 is
60, and then 3 is 60.
3 is going to be 60 because of vertical angles. 2 and 3 are vertical angles.
6 and 7 will be the same.
Because 6 and 7, yes, because 2 and 6 are corresponding, yes? In the same spot, corresponding angles are congruent. Since 2 is 60, 6 has to be 60. Well, 2 and 7 are alternate interior angles, yes? Which is? There's different ways we can get at this using alternate interior, alternate exterior corresponding angles. Any of these here. That's it. Questions on this here? For the most part, yes.
Want to get worse. Yeah. Let's enjoy this while we have it.
Measure of angle 8.
How many sections are there?
Not that many. No. So let's look at this here. So we're told that angle 3, because if they continue the 1, 2, 3, 4, 5, 6, 7, 8, angle 3 is 75 degrees. What is one of these that we know for sure? 2 is, and we're going with vertical angles because 2 and 40, 2 and 75 are vertical angles.
Okay, then just subtract 75.
Yeah, I mean we can.
Yeah, and then just get like.
So we can subtract 75 from 180, which is, so that'd be 7. So 5. So we get 105.
Yeah, and then you can get. Wouldn't that be like 1?
Because 1 and the 75 that we're given do add together to be 180, because any two angles that make a straight line do add together to be 180. They are a linear pair. But we're also, so we found out 2 is 75, yes?
Yeah.
What do we know about 75 and angle 6? Alternate interior angles. Alternate interior angles are congruent. So angle 6 is 75 degrees, yes? How about our 75 degrees and angle 7?
They're alternate exterior.
So they're on the same side of the transversal, yes? And on the same side of the line, yes? So they are
Of course.
corresponding. And corresponding angles are congruent. We also know 7 and 6 are vertical angles, so they have to be congruent. Now, we know we found out angle 1, yes? 1 and 8,
So 4 would be 2.
yes. Vertical. How about 8?
8, 5. I don't know how to explain it, but
Well, 1 and 8 are alternate exterior, so they're congruent. And well, 1 and 8 are alternate exteriors. 4 and 8 are corresponding, and 1 and 5 are corresponding. Like 1, because of vertical angles. Yes. Questions on these here? Because really, once we find 2 of the angles on both sets, we have the rest. Or really, once we find 2 angles, given that they are parallel, we have the rest of them. Even though we have 8 angles total, we only have 2 different values, yes? Any questions on this here? Any questions on anything we've done so far? Now, this here is actually quite interesting, because before y'all started this class, if we were given 2 lines and told one of the angles, well, to find the rest, we'd really have to measure. I would have to get a compass out and actually measure every single angle to get the information for the rest of them. But now, just knowing that the 2 lines are parallel in one angle, we've been able to calculate all 7. I haven't actually had to physically measure anything. Just knowing those 2 pieces, I can find the rest. That's what's nice about geometry. And the more that we do and the more that we dig into these theorems and postulates, the less information we need to actually solve the rest. Questions on this here? Do we feel comfortable with this? And as we've seen, with 2 parallel lines cut by a transversal, most of the angles are going to be one of 2 things. They're either going to be what? Congruent or supplementary. They're either going to be the same or they're going to add together to be 180. Because that's really the only 2 things that we have.
so that's what's going to be together.
We know that angle 115 and 4, these 2 angles are the same, yes? So angle 4 is really 115 degrees. Well, I know that this angle here is 115 degrees, and this one here is 115 degrees, yes? I kind of just went in and filled in what I knew. Well, none of those 115 degrees matched up to our x plus 5, yes? So that just tells me that x plus 5 degrees is not 115. But we do know that 115 and x plus 5 will add together to be?
Just 115.
Yes, if
Oh no.
they were asking for the value of the angle. What are they asking for? And I mean, we could do that, because what is that angle going to be? 65, yes? So I'm going to do this. Normally we wouldn't, because we would normally add those 2 angles together and set it equal to 180, yes? And our next step would normally, we'd combine like terms. So we would add 115 and 5, yes? I'm going to subtract 115 first. Now, you don't have to write this. I'll go back and do it the other way that you all are comfortable with. Because what is 180 minus 115? Because what did we say 115 in that angle add up to be? 180, yes? 180 minus 115 is? And at this point, we would subtract 5, yes? And get 60. Okay. Now, I'm going to erase this here. Because our normal way would to combine like terms. So here we would have x plus 120 is equal to minus x is same thing. Almost. Because that angle is 65, but x is 60.
Oh, I thought you like.
No. Any questions on this here? So we have this one here. So are 2x and 120, are they corresponding angles? Because 120 is below the line and to the right, and 2x is below the line and to the left. So they're not that. Are they alternate interior? No, because they'd both have to be between the lines. They are not. Alternate exterior, they would both have to be outside, yes? So they're not alternate interior, alternate exterior corresponding. And those three are congruent, yes? So if they're not congruent, they have to be equal to 180. And really, 120 and this one here are corresponding angles, yes? Well, the 2x and 120 do add together to be. And we can solve. So the first thing we can do is subtract 120, which tells us 2x is 60. Then we would. So x is 30. At least, yeah. Questions on this here? Question on anything we've done so far? Maybe the next one. Use property of parallel lines to find this here. So 1 and 7x plus 9 are alternate exterior, yes?
So they're both 136.
So 136 and angle 1 add together to be what? 180, yes? So one way we can go about it is saying 180 minus 136, which would give us 44. 44 degrees.
That's absolutely fine.
Right. And what do we know about 44 and 7x plus 9? They're equal. They're congruent, yes? Because they're alternate exterior. We could have also said that 7x plus 9 plus 136 is 180, yes? Either way works. At this point, we can subtract 9. And 44 minus 9 is 35. Because 44 minus 10 is 34. One less than it. Questions on this here? We good with this here? Let's look at the next one. What do we know about these two angles here? They're congruent. They're alternate exterior angles. So we could say that 6y minus 3 is equal to, what would we do first? Add 3 to both sides. Telling us that 6y is equal to. And last but not least, I believe that should be 22. Because 6 goes into 13 2 times, which leaves us an extra 1, and then 1 and 2. 6 goes into 12 2 times, so we should get 22.
I never thought of it like that.
Mhm. It's just long division stepped out. Questions on this here? Are you ready for the next one? Any questions on any of this here? We feel comfortable with these here? Yes? Now, I mean, we could make these quote unquote harder in that instead of saying here, angle 3 is 68 degrees and going about it this way, does 3 and 8 add together to be 180, yes? So instead of 38, I could say x plus 7. We can give 2 equations with variables. All that means is that
Just like equals
consecutive exterior angles. Yep, so they're going to add together to be 180. Well, 4x and 2x is. I was just, if we can make it quote unquote harder,
Are they ever going to do it like this?
instead of having just a number and a problem or an expression, we just have 2 expressions.
I have a question.
Yes,
Are they ever going to do it like that?
we can.
But it's like if they put
Well, that's just saying if we didn't have 68. And solve it, yeah. Because if we had 2 expressions, we still apply the same properties, but just dealing with 2 expressions instead of a number and expression. And the process would be the exact same. 1 is 9, 2, 169, we would divide by 6. And then we don't get a nice number because 2, 12, 49, 8, I think it's going to end up being 28 and a 6, but that's, don't quote me on that, I'd have to calculate that. Yeah,
Why was it 4x plus 7?
I just picked that. Yeah, I just decided. 49, 6 and 6 is 36. 42,
trying to get you to do it.
oh, yeah. 169 divided by 6. 28 and a 6. Okay, but again, I've just thrown that up there just to show you if we made it harder, it's just having 2 expressions. And really, on a whole, it's not any harder. Because if they were alternate interior, alternate exterior, the angles were the same, we would just set the 2 expressions equal to each other, solve for the value of x. And that's it. That's all we're doing for here. Yes. 4 through 10, even. 11 through 12.
Okay, maybe I lied.
4 through 10, even. 11 and 12.
Look at